And we're recording. Okay. So let's start by loading what you. Let's load up what you had last class. The slot machine. And the slot machine was what was due today. Really, if you were following along in class and your slot machine worked, then your homework for today is already done. If you weren't here last time, then please check the screen recording video on the website and follow along, and that will help you build the slot machine. Oh, I forgot. I got to load my slot machine. Hold on. Yeah, I think this is basically everything we had last time. Great. So that's that. Oh, wait, where's that window? Did I close it? I guess I did. All right, again, we'll start with this. What is left? Duh, winning. Right? So, yeah, we never put winning into our patch. So that's what we're gonna start with today. So let's go down here and let's just make sure that my slot machine is still working. Unlock the patcher. Oh, margins. I hate this. Again, if you like to have some buffer space below you like I do, just grab a comment and just drag it way down here, and then it'll give you some margin space. Yeah. So I'm hitting this, and that one stops. That one stops, and that one stops eventually. There. Okay, good. So that's working. And let me just check my notes. So I think the first thing we're going to want to do is I decided that the slot machine just took way too long because it can take up to 2 seconds per wheel, and that's just a long time. Hold on. Let me get into my notes. So the first thing that we're going to do, I think, is shorten how long it takes for each wheel to stop. Here we go. Great. Is everybody's slot machine working? Does anybody have any? Is anybody's not working? Does anybody have any questions on it? Okay, cool. Yeah. All right. So, in order to make it shorter, what's making it stop? Right. It's these logic. These three different comparison objects down here. They're less than or equal to objects. So we're sending these numbers that when the counter gets above that number, it closes the gate that causes the counter to count. So what we had up here originally, I've already switched it over on this version, but what we had before was this said random, all of these said random 100, right? And then down here said plus 100, plus 200, and plus 300. So we could cut this all in half by making these all random 50s. So start with that, and you've saved this as 3.1, right? So save as 3.1 so that you're not saving over your old patch. And so make all these random 50s, and then change the addition boxes down here from plus 100, 200, and 300 to plus 1, plus 50, and plus 100. So that cuts it down the amount of time by half. But there's one consideration that I realized, that what if this, because the random 50 gives us a number between 0 and 49. Remember, it gives you one less than the argument. And we're adding 1 here. Why are we adding 1, first of all? Any? Yeah, so why would we add 1? What is that avoiding? Yeah, that's right, it's avoiding the 0. Because if it got a 0, then that gate would be closed right off the bat and we'd never see a number on it. So, this way avoids a 0. But there's still a problem if we happen to get a 49 and then we're adding 1, then it's going to be 50. Then there's the possibility that the second dial gets a 0 and then the first dial gets a 49. So that would be, they both be 50 and they both stop at the same time. So in order to avoid that eventuality, or contingency rather, we would change this random 50 to random 49. That way we'll never get a 49. We'll always get a 48. So change that to 49. And then now go ahead and run your slot machine, and you should notice that it'll stop much quicker. But it's still random, because we're still adding random amounts to those. We're just adding less of a random amount, and we're cutting it off earlier. Okay. Any questions on that? All right. So if we want the computer to analyze the output and tell us whether we win or not, it's the same kind of thing as we're doing up here. We have to use logic. In logic, again, that's kind of how it's how you ask a computer a question, or how the computer makes a decision. It's all done through these little logic operators. And let's take a look at what. Just grab right-click on one of these less than or equal to objects and say open the help for that. You can also option click on it to open up the help. Okay. And take a look at this. At this little code here. Actually, let's grab this whole section of code. Just drag a box around it and copy it. And let's just dump it in our new patch over here, just so that we have this as our reference. This explains how each of these different comparator objects work. And they all work the same way. So the right inlet will set the number that the object is comparing. And the left inlet will trigger the calculation and will set the number that you're testing, right? So go ahead and let's go ahead and click on 4 on the right inlet values over here, right? And now click on, and nothing happens. You see, none of those toggles are lit. Now go over here and click a 2. And now you see that triggers the calculation on all of the objects at the same time. And then 3 of them came up with a true result, which is a 1, which causes a toggle box, which are these little X's here. Causes those to display the X, right? So 4 and 2 what this is equal to means that 2 is not equal to 4, so that's true. 2 is less than or equal to 4, that's true. Or 2 is less than 4, that's true. But 2 is not greater than 4, so that's false. And 2 is not greater than or equal to 4, so that's false. If you change this the left inlet trigger over here to 4, then that causes the greater than or equal to be true because it's equal, and it causes the equal to be true and the less than or equal to be true, but not the not equal because they are equal, and not the less than because it's not less than, it's equal to, and not the greater than because it's not greater than, it's equal. So that's how those work. And so before we were using those to look at the clock counter values that are coming in and determine whether we've gone over a certain threshold or a certain value. If it's less than or equal to that value. If it's greater than or equal to, then if it's greater than that value, then it will close the gate. So we're going to do the same kind of thing, but instead of evaluating whether we're going to close the gate, we're going to evaluate whether numbers are equal to each other. So we're going to start off. I'm only going to give you one win condition today, but you should be able to use what we do in class to figure out how to do some other win conditions, and that's going to be what the homework is. All right. So the first win condition is all the numbers are the same, and that's the one we're going to do in class. So how do you think we would do that? We could take the numbers coming from these boxes and just pass them into into this equals thing, right? So let's see. So how many different of these comparison objects would we have to use? 3? Well, we have to ask whether this one is equal to this one, and we have to ask whether this one is equal to this one. So that's 2. So we only need 2 in this case. So so let's try. So what is it? Equals equals. New object equals equals.
So does that mean we can only compare 2 numbers?
No, you can only compare 2 numbers with this object. If you need to compare more numbers, you'll have to do more than one comparison and then add up the results, and I'll show you that in a minute. So the first thing we have to do is compare the first dial and the second dial. So we could have this one come in here and this one come in there, and if they were equal, it should be a 1 over here, right? So if I took this and set this dial to 3, and then I went and set this dial to 3, it comes out with a 1.
Can you make the screen zoom in a little bit?
See? 1 when they're the same. So could we do that? Could we just trigger this? Well, look, it's 1 right off the bat, and it never stopped being 1. That's not going to work. Right? If I just put a button attached to this to kind of display every time it's putting out an output, you'll see that it's outputting a 1 every single time until that first one stops, and then it stops putting out a 1. But it's saying it's the same as the other one, even though it's not. So why is that happening? Well, let's take a look at the actual numbers that are coming into this box. It's called a POC object. I think I told you guys about this. PAK. So PAK will pack elements together to form a list, and we can use this to see what that equals object is getting. So send the output of the POC to the right inlet of the message, and go ahead and trigger your patch again. And you can see, look, the numbers are the same. Always. Why? Well, it's because the way we structured our patch, we have everything being driven by the same counter. So all of those wheels are going to step through their numbers at the same rate. And so they'll always be the same until one of them stops. So because this equals triggers its calculation. Whoops, what just happened? Go away. Stop that. Triggers its calculation based on this left input. This right input and the left input are always going to be the same. And as soon as they're different, this thing has stopped moving, and so it stops outputting it stops triggering that calculation. So the last thing that it calculated, they were the same. So that's what's happening there. So we have to figure out a way to get around that. Let's start first just by building the actual system to do this. So let's just reproduce our three wheels over here. Not floats, ints. 3 int boxes, I, and I. And then we're gonna have a couple equals objects. Duplicate that. And what we're gonna do, this one will come in, that one will come in there. This one, so we're comparing A to B. Let's put A, whoops. Get out of there. A. B. C. So we're comparing A to B first, and then we're going to compare B to C. So we can take the output of B and have it be the first inlet of this comparator, and C being the second inlet of the other one. Then have those pass to a couple toggles to just display whether they'll display whether it's true or not. We don't need to do this step, but it makes it easier to see what's going on. Okay, and then how do you think? All right, so let's just try this the way it is right now. So go ahead and put in manually, just put in some values. Put a 2 over here, and a 2 over here, and put a 1 over there. And oh, you know what? It's not outputting our values. We need to put a button up here and send it into each of these. Now trigger that. So you can see that the A and B are true, but B and C are not true because 2 and 1 are not the same. How do you think we could determine whether both of them were true? Yeah. So this equals 1. If this was over here and that was a 2 also, then that equals 1 also. How could we test for both of them equaling 1? Any ideas?
Equal to 2.
Exactly, equals to 2. So we could add them together, and we could test whether that equals 2 or not. And if it equals 2, then they're all the same. So the first thing we need to do is add them together. So we need a plus object to add, and send this one into this inlet and that one into that inlet, and send that into a message box so we can see what kind of outlet we're getting. And you'll see now if I bang this again, it's giving us 2. Whereas if this was some other value, like a 5, it would give us only 1 because this is true, but this isn't. So 1 plus 0 equals 1. And if none of them were true, if that was like a 1, then it's going to be 0 because 0 plus 0 still equals 0. So we can use that to determine whether or not it's true. So let's do what's called a select. You can either type out select or just push or just type SEL and select 2. You can get rid of that, send that into there. And if you hover over the select output outlets, it says the right outlet is input if the input doesn't match. And the left outlet is bang if it matches 2, right? And that's the argument we set was 2. So we can have a bang over here, and this is going to mean it's a win. Whoops. And and then actually a bang isn't going to come out of this. It'll actually be a value. A bang comes out of this one if it's 2, but it'll be whatever the number is that's not 2 will come out of this. But we don't really care about that number, so we're just going to convert it to a bang by sending it into a button anyway. And then this is lose. So that's a lose. Great. All right, so let's attach this to our wheels. Grab all this, move it down here. We can get rid of this POC stuff. Okay, so again, our natural inclination is to just connect these directly up, but you'll see that that doesn't work. It's just saying it's winning nonstop. So if you programmed it that way, you'd be out of money quick. Again, same problem that I showed you before. It's because all those numbers are moving together. So what we need is a way to send it when it's send all 3 numbers when the last number is done, right? So we need to store these values and then output them later. So there's a couple different ways you could do that. You could like send them into a message like that, and that would hold on to it, and then you could send a bang into this side. That would output the message. That's one way of doing it. The original way, and probably the better for learning. What just happened? Did I like? Oh, I know what happened. That's what happened. Okay. Let me zoom in a different way. There we go. The better one for demonstration purposes is creating what's called an integer box. So you can just type I for int, or you can type out int, either one. And this will, like a message, you can put the value in here in the right inlet, and it won't output until you send a bang into the left inlet. So
What integer box does?
that's what an integer box does. Yeah, it just stores an
Waiting until
integer.
bang comes?
Hmm?
Waiting until bang comes?
Exactly. If you sent it into the left inlet, it would actually just output that number immediately. But you need to make sure to put it into the right inlet. And then you can send the output of that to those number boxes. Right? And then what could I use to send a bang when it's done? To actually have those int boxes output their values. Anybody have an idea? Well, we have, what do we do? What's the last thing we do when the last wheel stops? We turn off this clock, right, with this timer stop thing. So when this gate closes, that's the event that we care about. When this gate closes, we're sending that value, which is a 0, to this timer, and that's stopping the timer because that turns this toggle to 0, and that is sending a 0 to the metro will stop the metro.
Can we add one more bang in trigger?
For right here? Yeah, exactly. That's what we want to do. We wouldn't in this case we wanted to actually send that value of 0 because that's what this metro, if you send a 0 to the metro, that's what stops it. But here we want to send a bang instead of a 0. So what we can just do is do a trigger bang, right? Or you could type out trigger, but all you have to type is a T. And then let's make a new send for this. We'll call this send game over. Okay, and game over. And then let's receive that game over here somewhere. And send it into each one of these bangs. I mean, each one of these int boxes. And so now it should store that value for us until the game's over. Something's going on though. That didn't seem to work right for me. Set value. Oh, I know why. It's because we're triggering this on every single value that comes out of this comparator. And instead, we want to trigger it when this comparator, I'm sorry, comparator. That's Isadora speak. This operator, this less than or equal to operator, right? This is outputting a 1 until it gets over. So each one of those 1s we're outputting this. So we're still outputting it way too often. So instead of doing a trigger, we actually want to select. We want to do a select, just like we did select 2 down here. We want to select 0 over here. That way when it gets to be a 0, it will send a bang out. And it won't send anything out in the meantime. That should fix this. Let's try it again. And now you can see those boxes don't change until and it still hasn't changed until that last one stops, and then bang, now it outputs its values and determines whether you win or lose, and it said lose because they don't match. So we could try this all day to try to get a win condition. It's just, it might not happen. But we could cheat it by make some test conditions by just putting a message over here. Let's do lucky 7s. Put a 7, send that 7 into each of these boxes. Like that, and then put a bang over here and send that into the game over, and that will test that function. So now this should output 7s into all those boxes, and then we saw that win. See the win? Cool. So that's a simple way of testing whether they're all the same. There's another way of doing that. This is doing 2 separate of these comparison objects. The other way you could do it is by doing what's called an expression. I'm not going to go into this too much, but if you wanted to use it for your homework this week, I would be totally cool with that. So let me show you jit.exp. Not jit. It's just EXPR. Yeah, EXPR. Okay, it's red because you haven't put an expression in it. It needs that. It needs its actual expression as its argument. But go ahead and open up the help for EXPR by option clicking on it or right clicking and say open help. So this can get very confusing. There's like a very specific syntax for how this works. But you can see right here on the help file, here's one. Let's just copy that. Actually, let's copy this whole thing into your patch. Grab all of that, copy it, get rid of that, paste. So in this, you can kind of see what they're doing here. They're saying $I1 plus $I2 times $I3, right? $I1 means $sign just means it's a variable. It's one of these numbers up here. I means it's an integer, and 1 means it's the first one, the first message that it got in here. $I2, obviously it's an int and it's the second. $I3, it's an int and it's the third. So you could do, let's change this from a multiply to a plus. And if you want to make it more clear, you can actually put spaces in between these. This could do the same thing as actually. Oh, so actually what we need to do is instead of plus, we'd want to replace that with our comparison symbol here. Equals equals. Whoops, not plus plus. Equals equals. And now this will actually do all of those calculations at one time. Right? But it works the same way, whereas the furthest left inlet is what triggers the calculation. So in order to really test this out right, you should put them in from going from right to left. Put the numbers in that you want to test. So lucky sevens, 7, and 7, and then hit the bang. Should output a 1 if they're the same. Why didn't that work?
Can I ask a question?
Yeah.
How does EXPR get the number if the bang is connected directly to EXPR?
So it would have, if you banged it before you put a number in, it would just be whatever the default number is, which is going to be by default it's 0, right? So that it would have a 0 as a placeholder. This is wrong. Sorry, this is. I'm missing something on this. This expression doesn't make sense. What I have to do actually is go $1 equals $2, right? And we basically have to do the same thing as we did over here, just in one step, with an expression. Then we have to add plus $2. I'm sorry, $int2 equals $int3, right? So what this is going to, I think that should work. Let me see if that works. We might have to do parentheses or something to really make it work. Yeah, I think that's not working either. All right, last chance. If this doesn't work, I'm going to scrap it because we don't really need to go over this anyway. Let me try this. I think if we put parentheses around these to define them as values, it's probably some kind of order of operations thing, and this would fix that. Yeah, so that now it's 1. Now it works right. So now we're saying this one this one equals this one. If that's true, the outcome is going to be 1, plus this one equals the middle 2 equals 3. If that's true, the outcome is going to equal 1, and then add them together to get 2. And that's basically the same thing that we did over here, just in an expression. And if you want to look more into expressions, go for it in the help file. We'll probably be getting back into some expressions later on in the semester when we look at how to use expressions to make video content and stuff like that. Let me just comment this. Expression. Okay. So just looking over here, let's forget about the expression stuff for a second and look back at what we did over in this stuff to figure out whether these were all the same. How about if we wanted to have a special condition that just tested for lucky 7s, where we're asking, are all of these inputs 7? What do you think? What would you do? Well, look at the first thing you do is these are the objects that are going to change based on what you're testing for. It's these equals objects. So all we'd have to do one just for 7 is we'd have to change this. We'd hard code this to 7. Here, let's grab all this code and copy it. And instead of having this be a floating variable that changes, we would hard code in 7. And we'd actually, in this case, we'd need 3 of them instead of 2 because we need to ask the question for every single one. Is this one 7? Is this one 7? And is this one 7? Get rid of that. See, we don't need anything in the left inlet or in the right inlet anymore because that's going to stay 7 because we're just testing for 7. And so what we would have to actually have, we'd either have to use an expression here to add all these together, or we could just do a cascading set of these plus objects. So we can have those two get added together, and then that gets added to this. Wait, no, that's a waste of time, sorry. All we need to do is you only need 2. Yeah, you only need 2. Because you can have this one, yeah, like that. And actually, but we probably, to make sure that this gets triggered at the right time, have this one be the right operand, and then this one be the left. That way, the calculation doesn't get triggered until this last wheel actually goes. And then send that in here, and then instead of testing for 2, we test for 3. So 4, 4, 4. Oh, we forgot our bang. I had to bang into each one of these. And then, so 4, 4, 4 should be a lose because it's not 7s. Yeah, and it's a lose. But but let's test it with 7s now. Bang. What? There we go. Why did it say lose? I have no idea. It must have to do with what an old value in the box. Let me try that again. Put something else in. 4, 4, 4, bang, 7, 7, 7, bang. Okay, I'm sure that's what's going on. Is it's an order of operations thing. Four, 4, 4. I think if I did it this way, from right to left, it would work. Yeah. So there's something going on with the right to left order on that, or the order of operations, but I'll let you guys try to solve that for your homework. So this is so this tests for all 7s. So that's part of your homework. So the rest of your homework will be coming up with the math objects to do an ascending condition and a descending condition, all the same number, and all 7s. So we have all the same number and we have all 7s. What we don't have is ascending and descending. So you'll have to figure out how can you make a 4, 5, 6 be a win, and a 6, 5, 4 be a win, or a 1, 2, 3 be a win, or a 7, 8, 9 be a win. So that's your homework for next week. Now we're going to look at some graphical user interface functions and objects to kind of make this slot machine look better, and that will also be part of your homework for next week, is to make this slot machine look pretty with GUI objects. So let's do that. Let's look at GUIs. Oh, any questions about this so far?
I have a question.
Yeah.
Your numbers.
Mm-hmm.
How are you? The only way I can change the number is by command and scrolling. How are you actually typing the number out?
You click on the number. You have to make sure that your either your patcher is locked, and then you click on the number, and then you can either type it or you can scroll it.
Right. Can you do it while it's?
When it's unlocked, yes, you just have to hold down your command key to override the unlock functions.
Right.
And then you can select it and
Just
scroll.
Yeah, okay, but you can't type it in while it's locked.
I guess not. I guess you have to lock it.
Cool.
Okay. Actually, I guess before we go into GUI, there's one other thing I want to do to kind of clean this all up, and that will also help with your GUIs. We're going to make this modular with send and receives. We've already done some of that, right? We did the we have a couple send and receives, these timer stops and this game over and stuff, right? What I'd like to do is have the section that does the comparisons, this logic section over here, have that be separate, be able to move it around using sends and receives. So let's break these connections here. Right here, these right here, right? So delete those. And here, I'll zoom back in. Maybe a little less. And we're going to add sends under here. Let's call them send wheel 1. Wheel 2. Get out of my way. And wheel 3. I don't need this 7 anymore. Get rid of that. And then, why does my, stop scrolling. And then let's grab all this stuff and move it out of the way. Actually, let me make sure I don't select those sends that we just made. Let's move this over here. And copy all these sends, duplicate with a Command D, and change them into receives by swapping the S for an R. Pumping those in there. Okay. Just cleaning up a little bit. And let's see. This wasn't incorporated in the patch yet. I'm just going to move that down here. Okay, so that's separated in this. Let's check, make sure that this still works. And it works, 256, that got sent over, so that's working. It's always best to separate out your patch into like little functions like this using sends and receives. That way you can easily, like if you wanted to encapsulate this into a sub patch or something like that, or you can use, it'll set you up for doing what's called the model view controller paradigm that we're going to talk about next week. It's a way of keeping the different parts of your patch separate from each other to make things easier to debug, easier to track, and easier to become modular so that you can use this little piece in some other program without having to remake it each time. Okay, so let's look at some GUI stuff now. There is a function in Max called presentation mode. And if you click on it, it's down here in the bottom. It's this like little whatever that is. I guess it's a I guess that's icon is like a screen or something, like a projector screen. And when you click on it, everything should disappear except for whatever you have added to presentation, which I already had because I copied this from my previous patch. Those were in presentation view before, but probably all you guys have a blank screen. So click on this down here to go out of presentation mode. Anyway, we can use this to create a GUI to hide all these extra objects and just present the user with the objects that make the patch work and hide everything else. So in order to do that, you just select what you want to add to presentation, and you go up here, and I believe it's under Object, and you go Add to Presentation, Shift Command P. This one's already in presentation, so it's only giving me remove from presentation as an option, but go over here, Add to Presentation. Or you can select everything that you want to add and do a Shift Command P. Then it will draw a, if your patcher is unlocked, it will draw a pink outline around it. That will let you know that it's in presentation mode, or presentation view. So what do we need to have in presentation? What do we want the people to see? Well, we want them to see the numbers, and we want them to see
Trigger?
this initial trigger, right? Yeah, because that's kind of the the handle. So let's add that to presentation. And now that you have these in presentation, go ahead and hit your presentation view. And you'll probably notice that your stuff is all over the place, like mine is. It's based on, well, when you first add it to presentation view, it's in the same location as where it was before, but you can move it. So move everything up toward the top of the patch. And this location is completely independent of when the patch is not in presentation view. So I can move all this stuff up to the top corner of my patch and use it, and it works with hiding everything else. And I can go out of presentation mode and everything goes back to where it was. You can also, in presentation mode, change the size of things. And that's independent of when it's not in presentation mode. So if you're unlocked, you can grab this button and make it a much bigger so that it's easier to hit. Okay. Well, that's okay, but it's kind of an ugly button. So let's look at, there's a few different GUI objects that are made for this sort of thing, like a button. One of them is called U button. No, wait, yeah, U button. Sorry, do new object. Not message, I hit the wrong button. New object, U button. And all U button is a, if you go into help for it, it's a invisible button that you can put on top of other things to turn it into a button. So like if you notice here, if you unlock your patcher on this U button help and you move this U button over here, this click here is just a picture, right? And by itself, that doesn't do anything, right? It's just a picture. But if you click on this thing over here, that's the button. So you can put that on top of something else, and it's see-through. When the patcher's locked, it's completely transparent, and turn that into a button. That's one thing you could do. So you could, if you wanted to, you could have a comment over here saying, like, I don't know, play. And then you could put this over it, and then they click on play and it works. You could have you could put a picture in there. Like I think the object is called fpic. And you could have, let's see, can I just do that over here? Maybe there's something we can do in Max 7 really quick. I don't know how that works, whether you can drag them in or not. Am I crashing? Don't crash. Save your patches. I might be crashing. No, it worked finally. I don't know what that was, what happened there, but oh, I guess that's what that picture looks like. Not video, images. Here, grab this cat. Okay, so yeah, you could also have a picture if you wanted to and have your U button on top of the picture. And that'll work also. All right, what's going on here though is the picture is in front of the button. You need to make sure that your U button is on top. That's another thing. There, if you go up here into arrange, you can say send to back. So I want to have the cat highlighted, and I say send to back. And now the U button is on top of the cat. And when I click that, I guess it should work. What, is that something else? Is that not a U button? I think that wasn't a U button. That must have been something else that I had put in, like F pick or something. Yeah, now that becomes a button, right? So if you wanted to create your own interface pictures in Photoshop or something, like you could draw a picture of a hand of a pull handle and then have that be a button. I'm just gonna do text today, so I'll show you that one. There's one that's already set up to make customized UI buttons with text, and it's called text button. Text button. Button with text. Yay. Go into this, open the inspector for text button by doing a Command I. And we can set the text down here where it says text off label. Let's put that as, I don't know, play. We want it as there's different modes here that you can change from button to toggle. We want it as a button, right? Because we wanted them just to push it. We don't want it to stay pushed until they push it again. So yeah, play. We can make this play be bigger by changing the font size over here. So change that to like 30. I'm going to change my color to something more exciting than that. Make it a dark yellow. And then I'm going to make my background color something more exciting than drab gray. Let's do like a green. I'm gonna click the color wheel and choose real green. And then I'm going to darken it a little bit. There we go. Now you can resize this button to whatever size you want. And it works just like a regular button. The bang comes out here. You can have it send text also, but we don't need to. And it has some other functions that we don't need. But yeah, let's use that and replace this bang with that button. With this text button. And then add this to presentation mode. And it's way down here because that's where I had it in the patch. So I got to move it back up here. So that looks a little better. Let's add, while you're in presentation mode, let's add a panel. New object, panel. Panel is just a panel of color, but you can use it to, separate parts of your patch visually from other parts. It's just a good way of making things look pretty. I'm going to change this fill color of this panel to something else. I'm going to have it, and by default in Mac 7 it does a gradient for you, and these are the different colors of the gradient. So right now it's fading from yellow to gray. I'm going to have that fade from yellow to red to give this kind of cool fire effect. And then put that on top of everything over here. And then I'll need to send it to back so that everything is behind it, so that it's behind everything else. And now I got the beginnings of a nice graphical interface for this.
I'm sorry, how do you put everything else in front of it?
So you would select the panel and go Object, Send to Back. Arrange, Send to Back. Or Shift Command B. All right. What else could we add to this? Well, there's one major function of the game that we haven't even added yet. Yeah, there's sound. Well, if we think about what are the parts of the slot machine experience? You have the play, the pulling the handle. You have watching the wheels and they stop. then then it tells you whether you won or not. And if you win, what happens?
You get money.
Yeah, you get a payout, right? So we need to add a payout system. In this case, we're not going to have any money, but we can reward them with, I don't know, sounds or something, right? So let's add some sound objects to this, and also use the win conditions to trigger some sounds. I guess the first thing we should do, actually, before we put sound in, okay, so go out of presentation mode. You see that this panel is now wherever you stuck it. That's where it is, and it may be obscuring some things. So you can move it to somewhere else when you're not in presentation mode. You can also shrink it down to a tiny little square when you're not in presentation mode, and when you go back into presentation mode, it will restore to its full size. So the first thing let's do is, with that, let's take our win evaluation part of the thing over here, and let's have it output some text that tells you whether you won or lost, because we haven't gotten that part in yet. That's not test for all sevens. That's down here somewhere. Okay. So all we have to do is have these bangs populate a comment box with the word "you win" or "try again" or something. So you could have, all you need is a couple comment box, a single comment box, and then put some messages here, a couple messages. And if you look on the comment, if you hover over this input, this is where messages can come in. And let's see, if you right click on this inlet, it will tell you what messages are possible for this object. And the one we're going to use is set, right? So if we have the word set followed by something, then it populates that comment box with whatever word or symbol we want it to display. So we can have set "you win," right? But we can't have a space because it will interpret that as separate messages. So in order to have this treated as a single symbol, we have to put quotation marks around it. So have this button here that's the win button, have that go to this set message, and then the set message go to this comment box. And if you click on it, it should put "you win" here. And then same thing over here, set quote "try again" or "you lose." And so now that says "try again" or "you win." Okay, we can add this to presentation. Shift Command P. Go into presentation mode. Put this up here. The rest of my patch somewhere. There it is. Actually, I'm going to move this panel to be bigger to enclose that. I'm going to move my wheels up. And I think I want this to be a bigger font. So I'm going to change the font size from 12 to like 30. Then you can do Command J will make the comments, the box be the same size as your comment. But actually, I guess we should test it to make sure that the box needs to be big enough to have everything in one line for either of those. I think "try again" is the bigger of the two. I don't know. Let's see. Set "you win." Presentation mode. Is it still on one line? Yeah. Okay, that works. Now, but the thing is when we hit play, it still says you win or you lose from the last round. We should probably make it so that it clears it when you hit play, and it doesn't put anything there until it determines whether you won or lost. Yes, question.
My play button doesn't
All right, let me look.
I won with 3 random numbers too, so I like this level.
work. I start out winning and then I lose every time.
That doesn't work.
That's probably not a.
No, you only have one.
Put it on toggle.
Right, and then in the other Yeah. So that should go to that. And so now if you trigger that, it'll change the text trigger. Here, maybe you can help me. I'm getting it. So basically, basically when this goes, see, it's only accepting whatever the last number is. So I always use the same.
Yeah. It's the U button. You can also, I think, select the object and hit option click and it'll pop up. Oh, it's
This
fine.
is
And it'll say
storing.
what an object is. Okay. So this is
This
a
one's
text button, but
broken
then
too.
how does it
Sometimes
connect?
some of these UI objects are actually like little Java.
It's supposed to wait for the last
So you delete the bit
Yeah.
and
It's like
then
it's
just replace this, yeah.
It's like it's
So if this happens
Nervous about
again,
doing that.
I learn everything.
Crash. Or you could save it.
My
close your
slot
crash.
machine, I just start out winning and then lose every time. I
Just
don't
go in.
So your send as wheel one.
Sorry about that.
Hey Jackson.
Yeah.
I am only receiving the last integer. Right, so it's like play it, and then it does the whole thing. That's first, just a second, but then this will just be whatever the last one. So they're all probably
Okay, you're having your sends on your number sends are wrong.
these here.
Send wheel one. Oh, I know why. You have it can't be a space. It cannot have a space there because it thinks it's a. You're sending the same value to the send called wheel,
But
and it's just ignoring the space one because the one is an argument.
oh wait, so there should be a space between
No, there should
S
be-
and wheel, but not in between one.
wheel and one. It has to be a single symbol.
I see.
Otherwise, it interprets that as an argument.
So then why did it?
Well, the reason why it's sending the last one is that was the last one to send things because it's the furthest. It's the last one to turn off, right? And they were all sending to the same send because all of them were getting sent to wheel, and it was just ignoring the 1, 2, and 3 because those arguments made no sense to it.
Well, that time it didn't send anything. It did the same thing for the receive.
Yeah, you have to fix the
Oh,
receives
oh.
the same way. Yes.
for some reason, everything disappeared in my presentation.
Oh, you don't have anything in presentation.
No, I already put it, and I was added in the size of the text,
Uh-huh.
and it doesn't make that power is in the presentation.
Okay, we'll probably got resized down to nothing. What you can do is
Give it space.
take these out of presentation mode and put them back into it. And that will reset them to this particular size. So select everything that's in presentation. And arrays, objects, remove from presentation, and now add to presentation. Where did they go?
I don't know. I don't know what happened, to be honest. And I tried command Z several times.
Uh-huh.
Nothing happened. Okay. Restart.
Is it here, just in a different place? Try saving and restarting. Relaunching. I don't know.
As you make your way up to the front of the room, I also have a question.
Okay, yes.
Okay, so I'll show you what happens in.
You suck.
That's not what I'm trying to tell you.
Yeah.
So when I hit play, it starts out with you win.
Okay,
And
so it's
then-
saying you win before you win.
Exactly, and then every time I don't even win. It's like go from winning to losing.
All right,
every
so go
time.
to presentation. Let's see what's going on with your how you're sending to your evaluator. So
I'm sure that's it.
scroll
Oh,
down.
sorry.
I don't know.
Just like that then. Yeah.
All right. So
Wheel 1, wheel 2, wheel 3. Wheel 1, wheel 2, wheel 3.
okay, there it is back.
What?
So what's going on is these into boxes. If you go into the right outlet, right inlet, it doesn't output until it gets a bang.
Oh my
But if
god.
you go into the left inlet like you did, it outputs right away. So you've negated the whole reason for doing that. So we just need to move these over
Okay, great. I'm glad it's
to that, to there. That should fix it.
fantastic. What did
It's a bang that you can put text.
Alright. Okay.
You
All right. So are we all together? Again? We ready to move on? Does anybody else have questions? What is the meaning of life? All right.
42.
That was we don't have quite enough time for that one. But all right. So one thing that I noticed that what's going on here is that if it says, if you lose or you try again or whatever, that will still be there the next time you hit play. And I think what we want to do is have it replace that with nothing until the win comes around, right? So let's go back into the presentation. Let's go back out of presentation mode, and let's add up here before it gets to even this trigger. Let's add a new send object, and let's call this one game. Sorry, make sure I have a send. S for send. Game start. So now that bang is going to get sent into the game start. Let's duplicate that and have a receive. Change that to receive. And wherever you have your try again down here, just duplicate one of these set objects or set messages and just take out the argument, take out the symbol, just have it say set and put that into the box. And if you click on that, that just removes everything that's in there. So now game start will actually will get this to we'll delete everything in the box. Actually, and you know what? We should probably see how we have receive game start, and this kind of information section right here is kind of a separate section from the evaluator. So we should probably use sends and receives here as well. So instead of these win and lose going right into these sets, let's add sends and receives. Let's have game win and game lose. Send game win and send game lose. And there receives. Now I can cut these cables. I don't need them anymore. And this can go to a different area if I want in the patch. So if you weren't zoomed in as like I was, this will make it a little bit easier to see everything. Okay, so let's see how that's working now. So when you hit play, it will erase whatever was in there from last time, and then it should tell me I lose. Try again. When I hit play, it should erase that. There we go. So that's the beginnings of a good graphical user interface. That's right, we forgot. I was going to do sounds. We got enough time. We're not gonna get into as much of jitter stuff today as I thought, but that's okay because the homework is mostly this, mostly just this slot machine stuff until next week. But we'll see how much we can get through. All right, so let's do some sounds. Yes, question.
Where did the send game start go again? Was it at the top?
Game start is right after this button.
Right after the top.
Yeah, and then that gets sent to this set right here, which makes that erase.
Yeah, what are you sending those sets to? I missed that.
Oh, it's set to this comment box.
Gotcha. Okay.
And then on the comment box, I have that added to presentation so that it shows up, and I have it with the font size of 30. Oh, I guess there's one other thing. We could have just a static kind of label. Let's do that. I'm gonna move this down. I'm gonna move the play button here. Make this bigger, and then and you can have a label up here like my badass slot machine. And I'm going to make the font size on this bigger. And you can actually you can change the font if you want to. I'm going to make this Cambria because I'm boring. You can select multiple objects and move them together as a group too. And that's kind of the basics of the look of this thing. If you guys want to gussy this up for your homework even more, like with pictures and stuff, go for it. That'd be great. Okay, sounds. So I've used sounds so far in this class. We haven't gone over them, but they've all been part of this like typewriter thing. And basically, the way it works is in Max 7, you can just drag sounds right onto your into your patcher from over here or from your Finder window, and it creates this playlist object. And then the playlist object, all you have to do is send it the number of the playlist item that you want to play. So if you want this typewriter to play, you send it a 1, and it my volume is up. It should play that. Why did it stop? Why isn't it playing? Darn it, that's why. What? I'm hearing something. It's just super, super quiet. All right. Screw me. I don't know. The volume must be turned down somewhere. What the hell? All right, whatever. I think it'll work on your guys's. Go ahead and okay. Sorry, let me check my.
I think because you have it toggled blue down there, and it's the audio on off
Where?
in the bottom right. You have like a master. It's audio on off
Where?
with the power sign next to your
Oh,
audio,
no.
the audio meter gain.
Warmer,
right.
warmer.
Oh, down there. You might be right. That's a Max 7 thing that I didn't know about. That's new to Max 7. Yeah, I think you're right. No, it's still not working right.
Maybe within your patcher, your sub patcher. I see the level.
Oh, there it is. Yeah.
You can see the level, but it's blue. It's actually the same thing for the audio meter.
No, it needs to be blue to be on.
Oh.
Yeah, I don't know why my levels are just extremely low. God, that's so stupid. That was not doing that a minute ago. If I hit this, does it still make? No, it still doesn't make sound.
It worked in the top of class.
Yeah, it did. It must be. I must have something else open that's overriding the audio levels. Yeah, the only one that works is the bell sound. Well, anyway, I guess maybe I'll just save and reopen, see if that fixes it. Oh, right, I haven't saved this. Save as 3.1b. I could open this one, which I think I know works. Well, now it works. Okay, I'm gonna take a look at this. We have a couple more. We still have 20 minutes. All right, so yes, it's working. All right, so this is the playlist, the audio playlist object. It's called playlist tilde. To separate it from, there's a similar playlist for video in Max 7. If you send it a 1, then it's going to play the first file. If I send it a 2, it's going to play the second file. Right? 2, 1, 2. 0 will stop everything. That 0 is not attached to it. So like, if I send it a 0, that stops it. Right? So let's see. What we want to do is build this over here. So right in here. So the first thing we'll do, let's grab some sounds. Go to the class website, which is sites.google.com/a calarts.edu jitter/jitter. And this is the class website, and you're going to go to class meeting 3 and go over here and grab some of these sounds. I'm going to use, and some of these are just different versions of the same sound. You guys can use whatever you want. I'm going to use slot game end, and I'm going to use coin win and slot. I'm going to use slot machine Lydian. So download those. And then when you have them downloaded, just drag them right into your onto your canvas. Where is it? Desktop. So when you drag it in there, it should create. Did it work? There we go. It should create one of these. And you won't be able to hear anything until you add this stuff over here. So what you need is, first thing you need is what's called an easy DAC, which is this guy down here. And that's what actually turns on the audio. So go new, easy DAC, easy DAC.
Justin, what is the name of the player?
The player is called playlist tilde. but it's easier just to drag the media directly onto your patcher, and then it creates one for you. Then you take the first two outlets of this on the left-hand side are its channel 1 and 2 audio. So if you put it straight in there, it's going to be at full volume. Right? So I think we'll want to put in a volume slider to kind of control this. Go ahead and open, I think it's called the live gain. Oh, yeah. Go. Actually, no. What's this one? This is the one I want. No, it is live gain. Okay. Add a live gain object. Live.gain object. New live.gain. Tilde. And then it will create this little volume slider, and then pass the audio signal into this before it goes into the Easy DAC. So into the channel 1 and 2 of this live.gain, and then out the first two outputs of the live.gain into the Easy DAC. Now I can turn down the volume. Okay, let's add the Easy DAC and the live.gain. Add that to your presentation mode so that your user can turn down the volume if they want. I'm gonna put them over there. Okay. So now basically all we're doing down in this section right here is go ahead and, so if you want to make your playlist have more than one sound, all you have to do is drag the second sound that you want, and in this case it's going to be the game end sound. Drag that over the playlist, but make sure that it's not a red square, but it's a red line. That will indicate where it's going to insert that. If it's a red square, it's going to replace that with this sound. We want to add to this, so we put it, have it be a red line at the bottom, and then it adds that as an item. I guess I can't undo that. I want to remove that. Oh well, it doesn't matter anyway. So now if we send a 1, we can have game start trigger this 1, which triggers the slot machine sound. When it's game over, it will trigger this, it will replace that with the second one, which is that sound saying the game's over. Okay. And then we can have a second one with the coin win sound. And then if you get the game win, then it triggers that to play. I have it in a separate playlist object because I want this to play at the same time as this. So if they were in the same playlist, then this would never play because they would trigger both at the same time, and this is the furthest one down, so this is only, I want them to be mixed together in that condition. So that's why they're on separate playlists. So if you win, this will trigger at the same time as that triggers. So if you've hooked it up the way it shows here, it should work. Cool? Everybody's working that way?
Can I see the patch again?
Yeah.
What's the name of the object with the meters?
So it's called live.gain tilde.
Gotcha.
It was originally a max for live object, but in max 7, all those Max for Live objects became objects that you can use in your Max patcher.
Are those integer or message boxes?
Right here, these are message boxes. And again, so we're just putting these values in. We want this always to be 2, and this always to be 1. And this one always to be 1. And what's coming in from this game start, game over, and game win are bangs, right? This is gonna bang that, that's gonna bang that, and that's gonna bang that. So, cool. We have about 10 minutes. Let's talk about jitter, I guess. Is there any other questions on this? Anybody need to see anything else? And you guys know what the homework is. The homework is make a really nice looking slot machine that works in presentation mode with graphical objects like this, and to have sounds, wind conditions. And the wind conditions need to be all the same numbers, conditions, all the same, a special one, all 7s. So you'll have to somehow define that to be different than all of the same. I want it to be even more special when it's all lucky 7s. Maybe a different sound, maybe a different message for all 7s. Something to denote it from just all the same. All 7s. Ascending. One, 2, 3, for example. And descending. 6, 5, 4. All right, so make sure for your homework you've accomplished these win conditions. And if you're having trouble, just contact me. I got plenty of time to do some office hours, and I'll help you figure it out. Also, you can work with each other to help figure this stuff out, and you can talk to Darwin, Trey, as your TA, and he can help you out probably too. No pressure, Trey. He hasn't actually. He's a beginner in this class too, but he did really well last semester as our TA. So cool. All right, let's look at jitter. So I think the first thing before we start playing movies and stuff in jitter, we need to understand what's going on. So make a new patcher. Save this one as class 3.2, and then go into, you can close the slot machine. Go into your help file, go to help, max documentation, and if you're not on the main window, go up here, click on the home to get to the directory. Then go down to jitter and click on tutorials. And what we want to look at right now is what is a matrix. All right, so jitter works in matrices. So what is a matrix? Well, a matrix is an array of numbers, like a chessboard. You can describe the position of this pawn right here, this white pawn. You can describe its position as 4E, right? Or E4, because it's over this. It's just like Battleship, right? It's a grid or an array. We can use this to describe pixels in jitter. Let's see. So that's a chessboard. You can do the same thing with numbers. Here you have A, B, C, and D, and with 3 different So you have a dimension of 4 on the x plane, and you have a dimension of 3 on the y, right? You have 1, 2, 3, and 4, and 1, 2, and 3 deep. And you have a 4x3 grid there. Now, video data, this is what this next thing is talking about. Video data is 3-dimensional. So that's 2-dimensional. It's giving you, just a XY grid. That's generally not enough information unless you're just talking about black and white to describe a video signal, because you have to tell what color each of the pixels are. So in Jitter, what we do is we have it be a 3x3 matrix, basically. It ends up actually being a 3x3x3 matrix. It actually ends up being a 3x3x4 matrix because there's an extra plane of just alpha channel. But essentially, this 3x3x3 cube can describe the colors of the pixels in a different area. So this first cell here where it says 1, you see that, so there's 27 possible cells in this, right? But this first cell 1 could have 1 here and then 10 in the green channel and 19 in the blue channel, right? So this is like the red channel has 1, the green channel has 10, and the blue channel has 19. That's how you could describe a pixel's color, right? So basically, yeah, this is saying what I just said about how this grid can represent a screen, a video screen. That's one type of matrix. And that's mostly what we'll use matrices for in Jitter, is for creating video in a screen format like this. But also, you can use matrices for whatever you want. You can use them to. The other thing that you'll often use matrices for is describing vertices of a 3D object. So you might have a matrix that gives you the x, y, and z locations of a point. So the first plane is the x locations, the second plane is the y locations, and the third plane is the z locations. But we won't get into that until the end of the semester. But yeah, mostly you have this you have a series of 2-dimensional planes. And in video, we divide those up into red, green, blue, and alpha, or RGBA, or ARGB, depending on what program you're using. Max generally uses ARGB, meaning the first plane, or plane 0, right? Because most computer things count from 0 up. Plane 0 is the alpha, plane 1 is the red, 2 is the green, and 3 is the blue. So that's what this is talking about. And again, you should go through all of this. That's going to be part of your homework, I think, is to go through some of these first couple tutorials, and I'll tell you which in a second. Yeah. So yeah, that's kind of the basics of how that's used to determine a pixel. Attributes. So Jitter, unlike a lot of the other groups of objects in Max, Jitter kind of all was added to Max all at the same time, and it was programmed by like the same couple of programmers. So unlike a lot of the other objects, most of the arguments and attributes in Jitter are the same for all Jitter objects. Whereas with Max, because Max is added by, it's been programmed by a bunch of people since the 80s, and they never throw anything away. You have all these older objects that are replaced by newer objects, and some of them have different syntaxes, and you never know. In Jitter, it's usually all the same. And it has things called attributes that are different than arguments. We've seen arguments, which are generally just like numbers, like here where it says counter 009. Those are arguments of the counter, right? The first one is telling you how it's counting. The second one tells you what its minimum value is, and the third one tells you what its maximum value is. Those are arguments. Attributes use this little @ symbol, and the thing about arguments is they have to go in the right order. The computer says, okay, the first argument is going to be the mode. The second argument is going to be the minimum, and the third argument is going to be the maximum. Attributes you can put in whatever order you want. You can say jit.brcosa at brightness 0.5, at contrast 2, at saturation 7, or you could do it the other way around. You could say at saturation 7, brightness 5, and contrast 2, and it doesn't care what the order is. In fact, really in jitter, there are no arguments. There are only attributes. But it realizes that people are used to working in Max, or at least people who've been working in Max for a long time, are used to working with arguments. And so it assumes if you don't put an attribute, this at brightness, if you don't put an at symbol and you just put in values down, it makes assumptions about the first 4 things that you put down and converts those into attributes based on their position. So that kind of works as an argument, but it's actually not really an argument. But those first 4 things are these right here. See where it says jit.rota 4 char 320 240. The first thing is how many planes, what's the dimensionality of the matrix. So in this case, because it's color video, we need 4 planes, 1 for the alpha, 1 for the red, 1 for the green, and 1 for the blue. So that's 4. Char, that's referring to what type of value it is, whether it's an 8-bit integer, which is what char is, meaning an integer that ranges from 0 to 255. That can be expressed in binary in 8 bits. That's char. If you need to go char that's bigger than an integer that's bigger than 255, the word would be long. But you generally don't need that. Usually you're going to be using char. The other types of data that you'll sometimes use is a float. That will give you float values. And then there's float. By default, that will give you float 32-bit float values. If you need really, really precise float values, you can do float 64, give you 64-bit float values. I think that's it on the types. And then the 320 by 240, that's the actual resolution or the dimensions of the matrix. So it's describing a video file that's 320 pixels wide by 240 pixels deep, and then each of those planes are going to be the red, the green, and the blue value for that. We have about 5 minutes, unless those of you who needed to leave at 2:50 can go if you need to. So that's kind of what they're talking about there. And yeah, I guess we don't really have much time to put anything in here. Let's see, we have 5 minutes. I can show you one thing really quick. Let's do to save time, let's do this one plane 2-dimensional matrix. Do a jit.matrix. And also all the JIT objects start with the word JIT. And then the arguments, or attributes in this case, that we're going to put in it are 1, right? Because we're saying it has 1 plane, and char 4, 3. We're going to make a really small black and white video file. So if you only have 1 plane and you're using it as video, then that can just describe whether it's a white pixel or a black pixel. You can use that to do black and white without any color. Now let's add what's called a jit.p window. And that's a patcher window. And take the output of this JIT matrix and send it into the P window. P window. All one word. JIT.p window. See that? Okay. So in order to actually have this thing send out its matrix, we have to actually send a bang to it. Of course, there's nothing in it right now, so it's going to be black, right? So we need to. We're gonna create this system really quickly to physically just set each of those values for this really small matrix. It's only 4 by 3 pixels, so this wouldn't be too hard. So let's do. We're gonna use a POC object, or a pack object rather, to create the message necessary to set the cells for this. So put in pack set cell, all one word, 0, 0, and val 0. So that is formatting. I didn't have a time to go through exactly what's going on there, but basically we're formatting a message that this matrix can understand. Let's put in a bang right here, or a button right here, and put in an int right here, and another int, and another int, and connect this one there, skip this inlet, and put this one in the end. Right? So now, if I wanted this pixel in this upper corner to be a white pixel, I could say pixel, I'm looking at pixel 0, 0, and I want that to have a value of 255. And you hit bang, and you still don't see anything until you hit the bang on this matrix, and then it actually sends it out. And now I have this white pixel up here. Try doing 2, 2, 255. Bang, still nothing happens until I bang down here and actually send out the matrix. Now it's added the white pixel down here.
I got
Yeah, mine's not doing anything, but I don't think I can really see the.
I got an L-shaped white thing.
What? Well, what was the dimensions of your matrix? Was it 4 by 3?
Yeah.
And did you skip this inlet right here?
Yeah.
And it just, what, does it look wrong or what?
It looks like your 2 dots, but connect them with a white line.
Yeah.
Yeah. Yeah. I can't. Oh, it's VAL.
Yeah, val, as in value. All right, so that's the basics of what is going on with Jitter Matrix, and it's just the very beginning of this stuff. So we'll start with this next week. We're done.
Yeah. Awesome.
You have a class in here right after me, or?
Yeah.
Oh, okay. What time's your start at 2? At 3?
3.
Oh my God.
That's okay. We can chill. We'll stop talking in the car.
The thing is Francesca has one in here that always runs long, and so I was hoping I was going to be able to offset my class by 10
I've got a bunch
minutes.
of weeks I don't need to be in here, so I'll let you know.
Okay.
You can just run late if you need to.
Okay, great. All right, thanks, guys. So you all know what your homework is?
Yeah.
It is file save as. Make the patch look pretty. Add win conditions. Yeah. Oh, and if you're not in the class, this is the last. If you're not registered for the class and you want to be, this is the last week to add drop. You gotta add by Friday. And if you want to drop, you gotta drop by Friday.
I'm dropping it.
And if you want to drop, fuck you. Just kidding. No, if you want to drop, please do.
Dear
don't-
God, please.
We don't want
drop
you
it.
here.
If you don't want to be here,
We don't want you here.
if you lose enthusiasm with Max, it's going to be a real headache to go through this semester. Yes. Yes, all questions, you got to wait till I'm out of the classroom and then I'll talk to you about them.
Nope.